Hello and welcome back to Calculus2 section 10.7 on root and ratio test. Now this is going to be a two-part, right? And tonight we are going to look at the root test. Ratio test will either be tomorrow or next week. I'll figure it out, but it will be as soon as possible. We have this left, and we have also 10.8, which is a survey of all tests. It's one of those sections, which test do I choose in what situation. We had these sections also for derivatives, pick the right derivative. We had them for integrals, pick the right integration technique. I think was like 8.6 or 8.7, whatever. So we are going to have 10.8 to be one of those sections. What's the appropriate test for the problem? But let's focus on the root test here and see the theorem. Now the interesting thing is that the conclusions of the root test will be the same as the conclusions of the ratio test. They're just applied differently. So here we go. Let summation a and b an infinite series and it's going to look like this. It's going to have infinite series of some kind of an raised to the nth power. So it's going to be of that form. Maybe like this, and then I don't have to draw this one. Well, whatever. Right, twice. So what do we have? Do the limit, well, it's going to more space. Do the limit as n goes to infinity of nth root, which is why it's called the root test, of an to the n. And that will have three possible answers. You will have answer which is less than 1, in which case converges, larger than 1, in which case diverges, equal to 1, test is inconclusive, meaning use other test. Right. So this is our problem that we have. So you are learning this, and the problems are fairly simple, I think. Summation of 1/3 to the n from 1 to infinity or 0 to infinity, whatever. 0 to infinity. You go, nth root of 1/3 to the n is equal to, oh, there's a limit in front. Oops. So you have limit n goes to infinity. And then these ends drop. You just have 1/3, which is 1/3. It's less than 1, converges. Done. There is nothing else to the test. Now we know this is geometric series and r is less than 1 and it converges, right? So this test can be done using multiple methods, right? So we have this test. I will just verify this one example. Let's try something else. Say you have I'm just looking at the book now. Problem 14 looks spicy. 1 to infinity, n to the n divided by 2 to the n. They have k's, I just move them to n's. All right, Well, we use algebra to put this into n over 2 to the n. And then we immediately take the limit, n goes to infinity, of nth root of n over 2 to the n. These guys again cancel, and we just have limit, n goes to infinity, n over 2. Well, that's infinity. Divergence. By the way, the hope is that you will never use root test on this problem here, because you can see right here by divergence test from 10.4 that it diverges because the limit is not 0, right? It's technically divergence test. I've seen a cool problem and oh, okay, there it is. I mean, looks terrifying, but you know, in my mind this is really cool. 23. Summation 1 to infinity of n divided by n plus 1 to the 2n squared. Right, so that's the problem. And the question is, what is this? Okay, well, we do the root of the whole problem there. So limit n goes to infinity, the nth root of n over n plus 1 to the 2n squared. See, the square root now cancels just one of these, and we are left with a limit n goes to infinity of n over n plus 1 raised to the 2n. That's an n. Raised to the 2n. So all this root test did is took out the square, right? Because you are dividing by the order of the root. So if you had 2n squared divided by n, well, then just they cancel and you just have 2n left behind. Okay, so I need to do this limit. And what we can do is we can maybe use L'Hopital rule. Do we remember L'Hopital rule from Calculus 1? Maybe. It's been years, right? Hopefully last semester. But we can assign this to a function and then ln both sides. So we are using logarithmic differentiation and the L'Hopital will kick in. So now I have ln y is equal to 2n ln of n plus 1. I forgot to put in the limit. Oops. So now when I plug in infinity, let's just divide n plus 1. I divide n plus 1 into n. It goes in once, multiply back, you get n plus 1. And when you subtract, these guys cancel, and you get negative 1, so minus 1 over n. That's what we get. I already know what the answer is, because the form is clear. But if you don't know those formulas, it's going to work out to be e to the negative 2. That's obvious just by looking at the problem without doing any limits. But if you don't know the formula for e, you don't know any of this stuff, right? So you have to grind through the calculation. So this thing inside, now I'm just going to call it 1 minus 1 over n. Now, when I plug in infinity, I get infinity over here, and I get a 0 for the second one, because 1 over infinity is 0, 1 minus 0 is 1, ln of 1 is 0. So I have the indeterminate form, a 0 times infinity. I have to change it, right? So L'Hopital rule, we still have the limit n goes to infinity. And we do the mathematical hocus pocus here, where we write this as 1 over 2n. There we go. And now, when you when you test this, you get 0 over 0. So this is where we apply L'Hopital rule. So L apostrophe H, where we take independent derivatives of numerator and denominator, and then see what gets, So we get 1 minus 1 over n, and then the derivative on top. So that's going to be the derivative of 1 minus n to the minus 1. So derivative of 1 is 0, minus the derivative of this is negative 1 n to the negative 2. So this is 1 over n squared. There we go. Now I have the derivative over there. That's just going to be 1/2 times negative n squared. Okay, cool. So this is our derivative. And the fastest way to solve this mess would be to multiply through by n squared. Oops. So we have ln y is equal to the limit n goes to infinity. When I multiply by n squared, I still have negative 1 over 2n squared on the bottom. That cancels, so I just get 1 on the top, and on the bottom I get n squared minus n. Now I deal with the double fraction here. I get 2n squared divided by, and I can pull n out, n minus 1. Now these guys cancel. And, oh, I lost my negative. See, there's a negative here. Has to be there. Because the limit clearly needs to be negative 2. So, to get y alone, we e both sides. And you get that y is equal to e to the negative 2. So our limit was e to the negative 2. That is 1 over e squared, by the way. That's less than 1. That's less than 1. So I'm going to take the... Yeah. So now, that's convergence by root test, because we have shown that the limit is less than 1. Now some of you might be interested in, how did I know that this limit is going to be e to the negative 2 and skipped all of this mess? Well, what I know from Calculus 1 and from Calculus 2, it's covered in both. Definition for e is a limit n goes to infinity of 1 plus 1 over n to the n. This is definition, calculus definition for constant e. Now, there is an improved version which says that if you have a limit n goes to infinity of 1 plus a over n to the bn, you will get e to the ab. So this is the better version. What did I have? I had limit n goes to infinity, 1 minus 1 over n to the 2n. Can you compare the blue and the black? There I say clearly a is negative 1 and b is 2. So I have e to the negative 1 times 2, that's e to the negative 2. Just by looking at the problem, I haven't solved anything, right? I wrote the problem down and I have seen that in a spot where a sits, there is a negative 1, right? Because there is a negative 1. I need that to be positive. So I just looked at the problem and I immediately knew this. But again, because I know these two formulas, right? And because I know them so well, I don't have to solve any of the stuff. If you don't know the formulas, well, logarithmic and L'Hopital, right, together to get you to the same conclusion of e to the negative 2. That becomes 1 over e squared. That becomes a very number smaller than 1, and it's convergence by the root test. Let's see if we can find one more example. You can also watch my older videos. They all have this mess. Well, now that we did the harder problem, easier problem should be a joke, right? I should have started here and then tested you with the other one. But here, try this one for some time or on your own. All right, so that should be more than enough time, because all we need to do is the limit n goes to infinity, nth root of 1 plus 3 over n to the n squared. The root is going to kill a square, and we just get pure exponential form right away of 1 plus 3 over n to the n, and you just get your e cubed immediately. That's bigger than 1. Divergence. Move along with your life. So that's the root test. You have to memorize the situation, right? That you get, either smaller than 1, larger than 1. if it's equal to 1, test is inconclusive, so you can't use root test. You have to use some other test, right? That's all it is. And you go from there. Just trying to see. So problem 36 is also, most of this stuff, if you can take the limit, it should be 3 seconds. Let's do 36 and then end this. Summation n goes from 1 to infinity. It's n squared divided by 2n squared plus 1 everything to the n. As soon as you see everything to the n, if it's not geometric series, you can hit with a root test. So limit n goes to infinity, nth root of n squared over 2n squared plus 1 to the n, and this is where the root kills the n, and we have a limit n goes to infinity of n squared over 2n squared plus 1. Well, that's a half, right? Because your section, right, the one that I mentioned many times, you have to review 2.5 from Calculus 1. In 2.5 you learn in limits at infinity, and those are these ones, right? Limits at infinity. And there you learn that if you have polynomials divided, if the powers are the same, it's the ratio of coefficients, so 1 over 2. Now, there was a way to solve this by dividing by the highest exponent. So we would divide by n squared, divide by n squared, divide by n squared. And because n is not 0, right? It goes to infinity. So you have limit n goes to infinity, and what you have is 1 divided by 2 plus 1 over n squared. When you divide 1 infinitely many times, that shoots to 0, and there's your 1/2. So that's what's happening in the background. But for the most part, right, if you know 1 over 2, then you can do this division, and that's it, by the ratio of front coefficients, right, 1/2. So what's left for us, and that's going to be the next lecture, and we can do it on Tuesday and end. Maybe do the lecture. No, we'll have to. Yeah, I'll have to post in announcements. So we have a ratio test left, and this one is important. So ratio test, and after the ratio test we have one more section, which is just pick your poison. Oh, we can do that on Tuesday, it's okay. On Thursday we do power series. Thursday will be the power series, next Thursday. And we can think about having the exam as soon as possible, exam 3. Now, for the final, there are some talks about having the final optional, which is something that, personally, I'm not in favor of, obviously, because if you don't know this course, if you don't have cumulative knowledge of this course, your differential equations will be just impossible. And you are welcome to go and watch some of those lectures on differential equations there on my channel. If you are looking to pass this course just to, get to the next course, you really need to know this course in order to advance. I'm going to tell you that in 2 weeks I will be teaching the power series solution to differential equation. And for the students who do not understand power series from Calc2, it's not even the foreign language. It's just impossible mess that they will never understand in 10 lifetimes unless you learn chapter 11. So learning this for the grade or learning this Calc2 course for the pass is completely relevant if you will be faced eventually with differential equations which use many concepts from this class all the time. So my next week in differential equations starting Monday will be all about Laplace transforms, which means they will be bombarded with integration by parts and integration by partial fraction decomposition, right? So those two will be the main topic of every lecture that I have for the whole week. And that's our whole chapter pretty much. And if you don't know those two techniques, you know nothing in this lecture. You can't do any of the problems. So, this course is very, very tricky. Now, we are moving, the whole department voted to have the option given to students. You also have the option from the college not to calculate your grade if you don't like it. So between those two, options you guys have, I just hope you learned anything in the course, because a lot of people just got relaxed, and it's gonna show in future courses. So that's what we have. I mean, situation is as is, and we can't change it now. So I will be back on Tuesday to finish this chapter, and then on Thursday we'll do power series, and we will take a look to have this exam as soon as possible for chapters 10 and 11. Chapter 12 has 3 lectures that are prepping you for Calc 3. So technically everything we did so far is preparing you for differential equations. And then chapter 12 is the only chapter that prepares you for Calc 3. So that's that part. I mean, there's a lot of integration in Calc 3 as well, whole chapter on integration, but, well, no, 4 chapters are on integration actually out of 7 or 6, whatever. So we'll see all of that. I will see you back on Tuesday. I am going to open the homework for ratio test, root and ratio as well, even though we didn't cover ratio. We can just skim through and see what are the problems that you can actually solve by taking the nth root of everything or kth root of everything, ignoring the other ones. Anywhere you see the factorial, right, n factorial and stuff like that, that's ratio test, okay? So you can immediately skip all of those problems because we will be talking about that on Tuesday. So and technically anytime when you will see mismatch of functions, so you have a polynomial and exponential and factorial and so on. So when you are mixing different types of functions, it's pretty much always ratio test that it's in charge, right? So we'll deal with that when we get there. All right, troops, that's it. I will see you all on, will the final be on camera? Yes, so both exam 3 and the final will be on Canvas. We are moving away from MyMathLab because unfortunately, right, people have issues connecting and so on. The servers were overloaded. It seems that it's okay right now, but I really don't want to risk it. I have a living nightmare to grade all of these things anyway. So there will be a special assignment open in Canvas where you will pick, problem number 1 will say, do you want to take the final or not? And problem number 2 will say, do you want your letter grade or you want your pass, no credit, and or just no credit, right, if it's D or F. Oh, by the way, if you score D in this class and you choose pass, no credit, you still have to retake Calc 2. So D, grade D, if you choose pass, no credit for grade D, you still have to retake the course because you did not pass with ABC. You passed with D, and D doesn't advance you forward to Calc 3 or differential equations. So that pass is in the name because A, B, and C means pass. No credit means it's not computed in your GPA. So if you have a grade D or grade F, you will choose no credit for an option, and then those will not calculate in your GPA. If you have ABC, you can choose, either to keep the letter grade or to use no credit, which means you can advance, but it will not calculate your GPA. And eventually I will upload when I get the chance. There will be, so the lab will be posted. I'm hoping to post it next week, and it will be posted on my MATLAB, and the lab will be open all the way through the final exam. So whenever I open it, it will stay open for like 2 weeks or something minimum, right? And you will have about 50, 60 problems there to solve, which is the course survey. Yes, if you choose to take the final, it will 100% count. That was a question that some professors asked when there was discussion on the department meeting. So the only option for, I don't like it, I'm backing out, is for pass, no credit for the grade. If you pick to have the final, it will calculate 100%. If you pick not to have final, then the average of your 3 exam grades will be replaced in for the final grade, because we still have to have those 30% of the grade computed. Final is 30%, right, of your grade. So you're either taking the final to fill those 30%, or you're opting out and you want to use your 3 exams to fill it in. And then, if your grade computes down to a C and you don't like the C, you just take no credit option, and it will not calculate in your GPA. Now, I understand that all of you are anxious about the grades. My position, can't care less about grades. I never did as a student either. I only cared about the concepts and what I learned, and then the grade kind of follows. I did say 5,000 times in this class, and I said it also twice tonight. This course you are learning for your DiffyQ. That's it. And the chapter 3 you are learning along with integration techniques from 8, chapter 12, and some stuff from chapter 8. That's for your Calc 3. So that's where your Calculus 2 is at, and I will be teaching 2 sections of differential equations in the summer 1, so you can join in there if you're interested, and we'll go from there. Alright guys, I have to go to catch this meeting that starts in 2 minutes, so I will see you all on Tuesday. If you have anything to say, either post in announcements in the discussion once I post the announcement, or shoot an email, and obviously you can put stuff in the chat. We'll go from there. We'll talk soon. Bye.